Hi everyone. In today's class, we're going to look at types or degree of saturation in solutions. So, since last class, you were introduced to the solubility formula, which is basically solubility is S equals mass divided by volume. In general, this basically means how much a solution can hold of a particular solute. Okay, so the mass here is of the solute, and the volume is usually the solvent. Okay. When we look at solubility, the solubility represents the maximum limit. Maximum limit of solute dissolved in solvent. So if we were to create solutions, we have to be conscious of how much solute we're adding into the solvent. If we add too little, it would make one type of solution different from adding too much. So to give you an example of this, let's say that we have substance A, and we know that its solubility is, let's say, 10 grams per milliliter. Okay, so if we had 50 milliliters of solution, the maximum amount that we can dissolve would be 500 grams, right? So this gives us a limit in terms of how much a solution can hold. So if we keep that in mind, okay, so this is some fictional substance A with a solubility. The solubility of substance can change if there's heat energy available. So for this example, we have to keep the temperature constant. Okay, so let's say this is the solubility at 20 degrees Celsius, which is room temperature. Okay, so if we look at the example below, let's say I give you 3 beakers. Each of them contains substance A. Okay, let's also make a couple assumptions here as well. Let's say each beaker contains 50 mils of water. Okay, some kind of solvent. Okay, so 50 mils of water. And again, it's all at 20 degrees Celsius. So if they all have the same volume, okay, depending on the amount of solute I put in, we will make 3 different types of solutions with different saturations. So let's say for the first beaker, I'm going to add in 5 grams of solute. Okay. If I add in 5 grams of solute in 50 mils of water, would that completely dissolve? Okay. Have I reached my maximum? Well, the only way for us to figure that out is to actually find the maximum for 50 mils. So the way that we do that is, if you have 10 grams in 1 milliliter, if the total amount of volume that you have is 50, how much can dissolve in 50 milliliters? Okay, so because we multiplied by 50 here, we would also multiply by 50 here. So that means this number is 500 grams. So that's the maximum that can be dissolved in 50 milliliters. So if we put in 5 grams, this is what's going to end up happening. So let's say that this is 5 grams of solute. All that solute will dissolve. Okay, so all 5 grams dissolve. And you would see nothing but a clear solution. There's no solute behind. But we've only haven't even touched the maximum amount that it can dissolve. Right? So if you dissolve all 5 grams, this solution here can still dissolve 495 grams of solute. Therefore, we call it an unsaturated solution. Okay. If you can still dissolve more solute in this solution, then we have not reached its saturation point. Okay, so it means that it's unsaturated. Okay. So let's go back up to the middle beaker. The middle beaker has the same amount of water. Okay. But here, I'm going to add 500 grams of solute. So we're going to have a whole bunch of solutes put in. Okay. If you add 500 grams, all 500 grams should dissolve. Again, your solution is clear. But the problem now is I cannot dissolve anymore. So cannot dissolve more. The maximum has been reached. Has been reached. So this solution is now called a saturated solution. Now, this saturated solution looks just the same as the unsaturated solution. As long as we have just met the maximum, they would both look alike. However, okay, if I went back up, and let me change the color of my pen here. Let's say at this point, I add 1 more gram of solute. What's going to happen? It's already reached its max. It's holding 500 grams. So if I added 1 more gram of solute, I will see 1 gram that's undissolved, okay, sitting at the bottom. Okay. If this happens, okay, whether it's 1 gram, 10 grams, 100 grams, right, none of it can dissolve anymore. In this situation, we have created an oversaturated solution. Meaning that there's still precipitate at the bottom. Okay, that's not dissolved. But the thing is, if I filter out that precipitate, okay, if I poured this entire solution through a funnel with some filter paper, I would still be able to collect the saturated solution. So the liquid portion is still saturated, but the entire solution now is called oversaturated. Okay, you cannot. Most people sometimes do use these two terms interchangeably, but there's a very subtle difference. So the unsaturated part is basically just the solution without any solid. Okay, and the oversaturated part is basically a saturated solution with solid. So it's a saturated solution with precipitate. Okay, that's what oversaturated means. You haven't dissolved more substance. Okay, and the solution, the liquid portion itself, the actual mixture, is still saturated. So let's look at the final example. So over here, in this third beaker, we're going to put in about, let's say, 1,000 grams of solute. Now we know the maximum is only 500. Okay, so when we put in 1,000 grams, we know that's way too much. But here's the thing. At first, only, so instead of all, we'll say only 500 grams will dissolve. And at the bottom, there's going to be a pile of undissolved solute. And there'll be about 500 grams that's undissolved. So we have 500 grams that did dissolve in 50 mils, and then we have 500 grams that didn't dissolve. Now, in this type of solution, let's say I wanted to dissolve that extra 500 grams. What might you do? Well, you could add more water. Okay, that would certainly dissolve it. But if you only had this much solvent, okay, if you only had 50 mils, and you cannot add more, but you wanted to dissolve all that extra, then we could just add a little bit of heat. So this is a special procedure. So we are going to now add heat to dissolve the extra solute. So obviously, if we're adding heat here, we cannot maintain that constant temperature of 20 degrees. Okay, at least not right now. But because we're adding heat, the funny thing that happens is all 1,000 grams dissolve. Okay, if you now let it cool to 20 degrees Celsius, okay, which is room temperature. what we find is the extra solute stays in solution. Okay. When all 1,000 grams dissolves, this solution again looks just like the other two. It looks clear. Okay, it looks like there's just water. Okay, because all that solute dissolved completely. Now, if you let it cool to 20 degrees Celsius and it stays like this, okay, then we have a special solution called a supersaturated solution. And supersaturated solutions are actually very unstable. Because if I were to vibrate it, shake it, okay, put some more solute in, all that dissolved solute now crystallizes. So if extra solute is now added, all solute precipitates. From the solution. Okay, and I'll show you a video of this in class, of this happening. Okay, because some of these are actually a pain in the butt to make, but if done successfully, it's actually pretty cool to see. So let's look back at the three types of saturated solutions that we've made, the different degrees of saturation. We have our unsaturated solution, which means that you can still dissolve more solute in that solution. You have your saturated or oversaturated solution, meaning that you have dissolved the maximum amount of solute in the liquid portion, and if you continue to add more, all it does is just precipitate out, and you'll get an oversaturated solution. And then we have that special case of a supersaturated solution that somehow contains more than the maximum amount dissolved. Okay, often it's unstable, and there is actually a procedure that you would have to follow to create that particular type of solution. So I hope all this has helped you to identify the various degrees of saturation that can be typical of a solution. All right, that's all I have for today. Hope to see you guys soon. Thank you.